have Professor Gerald of the Political Science Department with us. His research interests include public policy, and today he's going to talk to us about high-resolution satellite imagery.
Okay. Why do I, are you guys in here for a class? Is that what we have going? Students? I'm just curious. I didn't expect this many people. As I was introduced, I teach in the Department of Political Science, and my area of research emphasis is environmental politics, in particular, and public policy. And many of you are probably wondering why an earring-wearing tree hugger is talking about spy satellites. It's kind of a long story. I had a fellowship from NASA to do my PhD at Colorado State University, and there was a requirement in my department to do environment and space, and I ended up looking at a concept called environmental security, which brings in the possibility of using military technology, advanced military technology, to do environmental monitoring, for example, or to help out environmental cleanup, which the DOE does to a large degree now. And so I gravitated into this area and realized that there was a lot of activity, and published a couple papers and held a workshop here that we're going to talk about. So that's how come a tree hugger is interested in satellites. The talk today I'm going to give you is called Assessing the Implications of Commercial Spy Satellites. In the business we don't use the word spy satellites, but I figured in here it was safe. They basically don't want people to consider them spy satellites. The people who build these and fly them in the commercial realm just call them high-resolution satellites, but I figured here we'd be okay. Nobody would be upset. Give you an outline of what I'm going to talk about. I'm going to give you a technical and political history of remote sensing policy in this country. It's been sort of a tectonic process to get us where we are, that we now allow commercial high-resolution systems. At one point in this country, spy satellites, the satellites that look down from space for national security purposes, were among the most guarded secrets you can imagine. To the point where in the early 90s, when they started loosening some things up after the Cold War, the Congress discovered that the NRO, the National Reconnaissance Office, had just built a $1.3 billion building that nobody really knew about. And they were like, that's a lot of money. And they also found out they had like some very large number of billions of dollars of slush funds that nobody knew about. So this area has been protected from public scrutiny for a very long time. But public policy has changed, and now it's in the open. So I'm going to give you the technical and political history of remote sensing policy. I'm going to tell you what the current policy is on commercial satellites. Very complex policy. I'll see if I can boil it down for you. I'm going to tell you about some potential wrinkles in those policies, some things that have people like me a little bit concerned, that haven't been completely ironed out. And talk a little bit about the workshop that we had here in November, where we discussed the social, economic, and political implications of this technology, or at least of this technology becoming commercial. Just to let you know, I have a few pieces up here that I've written or participated in, including a bibliography, if you want basically what I'm going to say in a less condensed form, and you can sit down and read it. So it's in the pieces here as indexed here. Technical history. Give you the 5-minute version here. Basically, we had secret military programs dealing with reconnaissance satellites from about 1958 on. There are several really good books that describe how, in reality, the American space program was a reconnaissance program, spy satellite program from almost its very beginning. That's what they had in mind, believe it or not, basically from the early 50s on, when somebody at the RAND Corporation wrote a paper saying this was possible, and we started being denied access to certain areas of the globe that we wanted access to a large degree, and I think the arguments are pretty convincing. The spy satellite or the space program in this country started out as a spy satellite program, and they had some pretty amazing results pretty quickly. The first program was called Discoverer. This was in the open as it started. Probably nobody in this room remembers, perhaps with the exception of one. Between 1958 and 1960, they had Discoverer launches. They were televised. Everybody knew about them. It was a sort of hoopla, rah-rah United States kind of thing. Believe it or not, they had 11 failures in a row up until August 1960. So the Discoverer program was a total failure, but it ended in a success, which was the 13th Discoverer mission. And that led into the next set of programs that I can talk about here, which is Corona, Lanyard, and Argonne between 60 and 72. These are military programs which have now been declassified, and I'll show you some videos regarding those programs. Very successful, amazingly successful. They took I'll show you some images that'll show you how the resolution increased over that time period. It was just phenomenal what they did. We then went into some other programs. Basically, it evolved into the Keyhole program. That's the KH designation. So we went into, Corona takes us from KH1 to KH5, KH4B, excuse me, and then we went into the KH6s, into the KH11s, and there's talk of a new system that nobody knows much about, but that's the evolution of the classified programs, and I'll give you some more details on that. Unclassified programs began really in the late 60s, but we didn't get a launch until 1972, which was Landsat, the satellites that study the Earth. This has been through 7 satellites now, which kind of gives you an indication of how important civilian is versus military. They had 11 failures. We've only had 7 satellites total since 1972. Basically, they had over like 145 launches of Corona in that time period. But we've had 7 Landsat satellites. The last one went up last summer. It's working very well. One in the series didn't make it to orbit. That was Landsat 6, but I won't go into the detail there. So that's the unclassified program. There's also some other minor programs. A CSAT satellite was launched in the mid-70s, but it didn't last very long. It had some technical problems, but Landsat's been sort of the unclassified civilian program of talk in this country. There's other countries involved too with their own birds. Finally, into the very high-resolution commercial satellites, which essentially has been from 97 onward, although we didn't have a working satellite until August of this year. Or wait, did I get that right? September of this year? Yeah, September of this year. Essentially, there's been 3 launches or four launch attempts, and 3 of them failed until we had one up this September. The first was Early Bird 1, launched in December by Earthwatch right before Christmas. It failed in orbit. IKONOS 2 there's been 3 launches. IKONOS 1 was launched in April of this year. It didn't make it to orbit. Very low-tech problem. The cone that protects the satellite as it moves through the atmosphere didn't remove itself from the satellite when it went into orbit, so it was 1,300 pounds too heavy, and it just fell into the Pacific Ocean. I mean, these are just is real low-tech. We're talking explosive bolts that remove it, and they couldn't believe there was a problem with that. And then IKONOS 2, which was launched in September, which gives us about 0.83 meters, and I'll give you some nice images to show you there. There's some more coming up. OrbView 3 is going to launch sometime this year, which is another company. So that we are in the era of operational commercial spy satellites right now. Corona, as I said, started in the open as a Discover in '58. Operating in complete secrecy. After they had a successful mission, they totally stopped telling people they were launching them. It became absolutely secret. You couldn't talk about it in the government without going to jail, kind of thing. And that lasted until '72. Really interesting development in the mid-1990s. 800,000 images from Corona have been declassified and are available on the web, by the way. You can order them up if you want to look at them at the site, the USGS site listed here. Essentially, they were released for environmental research. The argument was they were collected over an amazing amounts of the globe. I'm not kidding you. You get on their selection system, you pick any point on the Earth pretty much, you hit the button and you're going to get 15 images from 1960 to 1972. Anywhere. I've tried. Okay? I've tried crazy places, the middle of the ocean, and they come up. So unbelievable amount of imagery. And the people who do environmental research said this is a great resource for detecting change. We have high-resolution images of the past. We can say what's going on, desertification or whatever. So really it was Gore and the people in the environmental sort of lobby that, within reason, that pushed this to have happen. There's also a Corona site available from the CIA, which is where some of my videos come from. And I'm just going to show you some videos here, let the egoists at the CIA tell you the story. They're very proud of this program. The CIA, just to let you know, Corona was a film return system. Essentially, they sent a camera into space. It photographed large segments of the Earth over a 2-week period. Near the end of the program, they could keep them up for a couple weeks. And then ejected a bucket over somewhere off the coast of Hawaii in the Pacific. They catch the bucket in the midair with an airplane. You'll see a version of it, and they then developed a film. So you actually have images. You have, film, like an image you would get off of a regular camera, which is different than what we have today. And I can talk about that. Let's see if I can get this to work.
The Corona program was envisioned to be a series of satellites that would carry cameras to photograph denied areas. orbits by 4 boosters. The spacecraft would fly at approximate altitudes of 100 nautical miles and take pictures of selected target areas. The exposed film returned to Earth in capsules ejected from the satellite would be smashed in mid-air over the Pacific Ocean and airlifted to processing facilities.
Okay, I'm just going to walk through these different. I have about 5 of these, 6 of these.
By May 1960, the Corona program was well underway. There had been 11 launches, none of which had achieved mission success. Then, an incident occurred that added urgency to the mission. The shoot-down of a U-2 flight over the USSR on the 1st of May. With aerial photography now denied the nation, the United States urgently needed an alternative. And Corona became that alternative. While the program began as an interim, short-term, high-risk effort, it far exceeded early expectations.
That's gold-plated.
And would deliver, as history tests, better quality and more plentiful polar reconnaissance than the U-2.
That's a gold-plated bucket that they drop him out of space from.
Just 110 days after the U-2 incident, Corona had made a quantum leap in intelligence gathering by operating from the new high ground of space. 3,000 feet of film were acquired on Discovery 14's historic flight. More than 1,650,000 square miles of Soviet territory had been photographed for interpretation, providing more coverage than all of the U-2 missions over the Soviet Union throughout previous years. Data like
One
this
satellite.
helped build confidence in the measures taken by our national leaders to counter the growing Soviet threat. Corona was not an instant success. The first 12 launches were failures for various reasons.
God, there's an out of order. Yikes.
The range from launch vehicle misfire on the pad to failure to achieve orbit. And there were instances when, having achieved orbit, the satellite actually entered an incorrect orbit. There were improper capsule ejections and camera failures.
In the history of Corona, one of the funny stories is that a capsule was ejected over Brazil, and it fell into the rainforest, and some of the natives found it and thought it was like some alien from space and just absolutely destroyed the film. They tore it into a million pieces. So when the CIA arrived, it was pretty much useless.
Constant technical improvement was a hallmark of the Corona program.
These guys had so much money, it was ridiculous.
Engineers were continually challenged to improve the program's capabilities. Early missions used acetate-based film, which crumbled and jammed repeatedly in spaceborne cameras. To solve the problem, Eastman Kodak developed the capability to coat a high-resolution emulsion onto a polyester base. This new polyester-based film could withstand the vacuum condition of space. And in later improvements, it was made thinner, permitting the spacecraft to carry more film, thus increasing mission duration.
Yeah, the amount of money spent. There's a quote, a famous quote by, I believe, Eisenhower, one of the presidents, might have been Johnson, who said, you know, we spent X amount of dollars on satellites, basically, and it was worth every single penny and more. Because what they figured out was that what the Russians were telling them about their capabilities weren't true, and we could adjust ourselves to reality rather than to their propaganda about their military capabilities. Here's the last one.
145th and final Corona launch took place on May 25th, 1972. Having achieved its purpose, Corona's existence is now unclassified, and its artifacts have been made available to the Smithsonian Institution, so that others might gain a sense of how far-reaching the program's unsung heroes were in their pioneering efforts. The camera and 2 buckets from Corona's last flight will be part of a permanent exhibit at the Smithsonian's National Air and Space Museum.
Okay, so that's the CIA's version. What I want to show you here is an example of, this is the first usable image from the Discoverer 14 flight. It's a runway and parking apron somewhere in Kamchatka. And here is what they had just 7 years later as an increase in resolution. Not only was it just an increase in resolution, they also had the ability, this one lasted for about a day in orbit, and these could last for 2 weeks, snapping photos of the areas that they wanted to get. The idea is we go from this grainy, I don't know what the resolution would be here, maybe 30 meters, 15 feet, maybe 15 feet, I would guess, maybe 30 feet, down to that image where you could probably almost see, you know, a person if you blow it up far enough in 7 years. That's the march of technology, so to speak. Give you an idea of what happened after Corona. KH6, which replaced the KH4B, the last Corona system, was the first electro-optical system. That means that you don't have film coming out of space, that you basically beam down electrons and you use computers to analyze stuff. The resolution, they haven't declassified this stuff yet, but it's coming, is around a meter, I would guess. We then moved on to the KH9 in the mid-70s. This is the first near real-time spy satellite. Essentially, just after Carter took office, they came in and showed him images of what was going on in the Kremlin that morning. And near real-time means that you can see the images nearly as, certainly within technical effective time. Resolution well under a meter. We then went to the KH11s, which is the current, as far as I understand, the current operational keyhole system. The resolution is on an order of a few centimeters. Nobody really knows. And now there's rumors of a new system, but nobody is exactly sure what the capabilities are, obviously. Another system that I'm kind of interested in is the LaCrosse system, which is a high-resolution synthetic aperture radar system, about a meter. Why would we want a radar system? See through the clouds. And at night. You can get it, if you have resolution down to a meter with radar, you can see what's going on an airfield at night through clouds. It doesn't matter. And LaCrosse is able to do that. Very powerful system. So that's the technical side of the military systems. Move now to stuff I know a little bit better, which is the civilian systems. My dissertation was on Landsat, the policy history of Landsat. This, as I said, started in 1972. To give you an idea, we were already in 1968 looking at the Pentagon at that level. This is what we had in the unclassified area in 1972 was the multispectral scanner, they called the instrument, which had an 80 meter resolution. They called it multispectral because it broke the light up through a prism, and you can study some very interesting properties of plants and soils that way if you break the light up. So this is what was going on in mid-70s. The MSS lasted until the late 80s, that part of the program. But here we are on the civilian side with a 30 meter resolution, or 80 meter resolution on the Landsats 1 through 5, essentially. Different program, right? They weren't looking at detail, they were looking at resources, so we didn't need the level of detail that is needed by the people doing military stuff. Some neat pictures though, Boston Harbor in '86 at 80 meters and Beijing in '76. Cities generally turn up blue in those images. Here's the next system that came out that was an improvement upon the multispectral scanner, was the thematic mapper on Landsats 4 and 5, also on 6, which didn't go to orbit, and 7, which is in orbit now. This is a 30 meter resolution system, and here you have images in true color, which is essentially what your eye would see if you were looking down from space, of the Poás volcano in Costa Rica, which I've been to, so that's why I chose the image. And then also a 30 meter image of Miami. So we're increasing in resolution, but we're not heading towards this super high resolution stuff that the military has for a number of reasons. They're more interested in resources. Let's see. Here's some recent images from Landsat 7 that I found pretty interesting. This is the 50-mile-long super iceberg B10A it's off Antarctica somewhere, floating northward. It's taken last winter by Landsat 7, which has a 30-meter thematic mapper, a version of the thematic mapper, and a 15-meter panchromatic, which means black and white camera. Just to give you an idea, this scale here is 1 kilometer. These are basically up to a kilometer and bigger icebergs breaking off of this 50-mile-long piece of ice. Many people suggest that this activity, which is fairly hasn't really occurred at this degree, is evidence of global warming. That the ice sheets are breaking up, and we're going to see these larger more dangerous icebergs floating north. I mean, this thing is easily to track. Ships don't go anywhere near it. But we have mile-long chunks being spread along behind it through the ocean that are very dangerous to shipping. I like that image. I thought it was kind of timely and neat. On to the commercial VHR systems, very high-resolution systems, or SPY satellites, as some people like to call them. Space Imaging is the star of this show with their bird IKONOS 2 in orbit right now. I brought in their sort of spokesperson for the workshop who displayed images for the first time publicly from that satellite because they hadn't had them out besides on the internet before. They are one of 8 U.S. companies who have obtained licenses to launch 1-meter commercial systems since '92 when the laws were changed. They attempted to launch IKONOS 1 in April and the satellite failed to reach orbit. They now have IKONOS 2 in orbit, and here are some images from that satellite. There's the launch. It was a small expendable launch vehicle. It's called, gosh, I can't remember the name of it, commercial system. So here's an example of image comparison. Here's a 10-meter system. This is, I believe, San Francisco Airport. 10-meter resolution, 5-meter resolution of the same thing. You're essentially looking at this area right here, and that's what happens when you get up to 1 meter. Pretty big difference. One thing that's very different in these two systems, as you move down in resolution, or up as you would like to say, your data stream increases phenomenally, like unbelievable. The amount of data they have to transfer in a 1-meter image basically means that you do smaller areas. You do tiny little areas when you image at 1 meter. That's a big deal, moving all that information. Here I want to give you an example of a comparison between what the KH-4A was doing in '67, that's the Washington Monument, and the first publicly released image of IKONOS 2 in October, which also shows the Washington Monument. Difference? What's the difference? If you're following me, you know what the difference is. This is an image. This is like a photograph, right? You're going to hold it in your hand. This is all digital. 11-bit data. At the workshop, I can tell you, when we talk about the workshop, there was a woman there who got some of the early data from space imaging. It was an image of San Francisco. The woman was jumping up and down. She just said, she does a lot of image classification work, and she said, this 11-bit data is so powerful that we could classify rooftop gardens in the shadow of the Transamerica building in San Francisco. They could pull out the fact that there was foliage on the roofs of buildings in the shadow of the Transamerica. I'm talking about levels of grayscale that I don't really understand in imagery, but she was very, very excited. She said, I hadn't been excited about this stuff until I got a hold of it, and she said, it's really, really powerful. Really powerful. Here's some fun images I asked you guys to identify. What are we looking at there? Right? That's Giza. Anybody know what that is over there?
The first one in London?
Right, Millennium Wheel in London. They were just erecting it. You can see the tugs out there pulling it up with the guy wires. So very interesting. These are IKONOS images blown up. Okay, give you an idea. I don't know how well you can read this. One of the persons presented at the workshop talked about all the systems online or being planned. Essentially, the ones at the top are Landsat-like. That's medium resolution up to 30 meters or so. The group at the top. In the middle here, we have high resolution panchromatic and very near infrared, which is the IKONOS type satellites. More high resolution here. Down here, we're into hyperspectral and radar systems. Just to give you an idea of all the countries involved and all the satellites that are planned to be launched in the next few years. You can see the timeline at the top, obviously into 2000 now. Some Landsat stuff coming up. Lots of commercial spy satellites essentially on the horizon. Everybody from India to Canada to West Indies Space to the Israelis have a system too. It isn't, I don't see listed there. Actually, it's under West India. So just to give you an idea that it's going to be a pretty active area pretty quick-like. We have one bird now, but there's going to be a lot more. Because people think it's going to be profitable, and I tend to agree. So what I want to do now is switch over real quick and give you a little bit of the policy stuff. That's the technical side. Hopefully I can get back in there when I need to. What I do is look at the evolution of policy in this area and also the implications of these developments for political and social things, including the environment, which is my area. I'm probably going to need to dim the lights again. One of the papers that you can pick up here, basically this is the heart of the paper. which talks about how we got to where we are. How did we move from a place where satellites, high-resolution satellites were so protected that you couldn't talk about them without going to jail, to an era now where if you have a credit card and access to the internet, you can download an image of anywhere in the world, except for, does anybody know where you can't get an image of?
DC?
You can get an image of Area 51 if you want.
DC?
No. Israel. Israel has a blackout, and we're going to talk about that as a policy wrinkle. I'll run through this as quickly as I can so we can get through this, this part. Essentially, U.S. remote sensing policy dates all the way back to 1955 when Eisenhower proposed his open skies principle. Anybody do diplomatic history? What was open skies? Probably the most revolutionary or crazy thing that Eisenhower ever did. He walked in to a summit with, who was in power at that time? And he said, you know what? We would really like to know what's going on in the Soviet Union, but we can't. How about if we allow you guys to fly over our territory, will you allow us to fly over your territory? It'll be a good thing. And the guy said, you're nuts. Never going to happen. That was the beginning of the idea that we needed to know what was going on in a real sense. The open skies doctrine, of course, was rejected, but it was the beginning of what we have now as a policy for remote sensing policy. Basically, as I told you before, from 1960 to the present, the U.S. developed increasingly sophisticated secret space-based intelligence gathering capabilities, and formally in the open promoted this open skies idea. However, informally, it fashioned a gentleman's agreement with the Soviet Union over satellite overflight. Originally, when the Soviets learned that Corona had worked, they said they were protesting diplomatically that this was not legal, they couldn't fly over with the satellite, blah, blah, blah. So what did they do? They built their own system. And as soon as they figured out how useful that system was, they shut up diplomatically. And the U.S. was for a while trying to figure out what was going on because they changed their stance so dramatically, and then we realized they had their own systems. So what we had was really a gentleman's agreement which said, I won't talk about your systems if you don't talk about my systems. And that lasted, believe it or not, all the way through the Cold War, although there was some open discussion later on. 1972, we get the first commercial a civilian system. It was a U.S. government, basically a research satellite, Landsat 1. After a few launches of that birds in that series, we had a policy sort of discussion about resolution. In 1978 and 79, Carter sets a 10-meter resolution restriction on U.S. satellites. He did that because the French were talking about launching a system of their own and going below 10 meters. People, when they were talking about building the new thematic mapper on the Landsat series, wanted higher resolution. And he said, well, okay, higher is okay, but we need to have a limit. And the limit he set was 10 meters in 1978, 79. 1982, we get Landsat 4 launch, which had the thematic mapper 30 meters. We weren't pushing the 10-meter barrier, but we were definitely moving up. And also in 1980, we had the election of Ronald Reagan, who came in. Does anybody know what Reagan did with Landsat? It's kind of arcane, I understand. He privatized it. He basically said, we've spent some odd hundreds of millions on this program. I'm into reducing certain costs in the government besides the military. Therefore, I'm going to make it private. And he tried to make it private. And that was the 84 Landsat law. Didn't really work out. Eventually, it was taken back into the government in the early 90s. But that was another major change. They made it truly commercial. They also passed a segment in that law which said, if a private company wants to launch a satellite, they can, but they have to talk to the government. They have to get a license to do that. And that was another significant part of the process to get us toward commercial spy satellites in 1984. 86 and 87, we had the launch of Spot 1, which was a French satellite down to 10 meters. They were already talking about going down to 5 meters at that point. And so in 1988, basically we had competition internationally. Reagan did a secret national space policy directive which removed the 10-meter restriction set on by Carter and didn't really set a limit but just said we'll talk about it. But we don't want to handicap U.S. companies vis-a-vis the French, therefore we're going to lose our restriction. And I'll move through this a little quicker. 89-90, we have the largest political shock in the history in human history, the end of the Cold War, I would suggest. As far as global importance. That changed things within the security establishment which had been basically holding on to this technology. I mean, they were vehement about keeping this secret. Vehement. It's literally, you would go to jail if it was mentioned. The name Corona was mentioned, you could go to jail, for instance. They started loosening up a little bit for a number of reasons. Basically, the Cold War was over. They started thinking about their jobs and thinking, well, maybe if we use it for other things besides secret things, it'll be around a little longer. Those kinds of things. Another major shock from the outside was the Gulf War. What happened in the Gulf War? For the first time, because of the loosening of restrictions on imagery, the U.S. military shared its data with the rest of the world. Its spy satellite data in that war for the very first time. And our allies were amazed. They could not believe the information we could extract, how timely the information was. They were literally floored. They had no idea that this capability existed. Some of them did, but for the most part they didn't. And that led, believe it or not, to this ramp up of high-resolution systems around the world. The French now have a Helio system at 2 meters. The Israelis have a system at around 2 meters. And essentially it's because they saw what we could do. They saw what we could do. Mid-1991, according to my research, a memo was written in the CIA, which was kind of very interesting, or NRO. This memo said, look, things are going on in the world. There's a lot of spy satellite activity being ramped up around the world. And it's in the U.S. interest to promote a U.S. company to fly the first commercial system. And it's in the U.S. interest because if it's in the U.S., we can control it. If the first system goes up and it's French, and they corner the market and drive out any other competitors, say a U.S. competitor, we have no control over that company. So the security people are thinking way in advance. They're thinking 10 years in advance. What's it going to be like in 1999? And they say, we want an American company with a bird up first, and we want some control. And that's what they got. We'll talk about that when we get to the policies. We had, as I said, in 1992, the Land Remote Sensing Commercialization Act, which took basically brought Landsat back into the government sphere after a failed attempt to commercialize it. It just wasn't, the resolution wasn't good enough to drive the market, and it failed. Some more changes there. Finally, in that law, we had another piece that talked about the commercial or the licensing of commercial systems, which made it much easier to do that. And all of a sudden, in late '92, as Bush is exiting his office, they get the first application, and it's approved within a few weeks for Earthwatch's 3-meter observation satellite. That was the first approval of a commercial spy satellite. And you can kind of see how that all came about as a result of these changes. What happens next? The next thing that happens is we okay a system at 3 meters when Bush is on the way out. Clinton comes into office. All of a sudden, Lockheed Martin and some other people, Raytheon and some others, propose a 1-meter system. All of a sudden, Clinton's like, okay, 3 meters is all right, but 1 meters really represents a quantum leap in the amount of information you can gather from an image. Therefore, we're going to talk about this again. They brought everybody back together, the military, the Department of State, all these people back into closed room discussions, and they said, what are we going to do? We have a 1-meter application for a system at 1 meters. We have an application for a system at 1 meters. And they eventually, in March, issued Directive 23, Presidential Decision Directive, which said, okay, no resolution restrictions. You can build a system at whatever level you think you need to. We're not going to say no. We have to okay that through our licensing procedure, but there's no restrictions. They also said, we will allow turnkey systems to be sold internationally. We'll discuss it. They haven't allowed it yet. They say, we'll discuss it. Turnkey means somebody else has control over it, the Saudis or whoever wants to buy it. And I could probably run through some more of this. Some interesting wrinkles. Eyeglass Saudi affair in 94, 95, so we get an okay for a 3-meter and a 1-meter system. Other companies are jumping on board too. All of a sudden, Eyeglass, which is another company involved in this area, has an agreement with Saudi Arabia to build a ground station in Saudi Arabia so they can downlink their data from the satellite themselves. This is another company trying to get involved. Whoa, the Israeli lobby went nuts. They were like, we are not going to allow our territory to be imaged by a system that downloads into the Mideast. We're not going to do it. It's just too scary for us militarily, a spy system. And so what did they do? They went to the U.S. government, and after all this time when the U.S. government was promoting the legality of overflight and collecting data over any place in the world, they blacked themselves out. There is a rule that says the U.S. satellites cannot image Israel at any resolution greater than what's otherwise commercially available. The only country in the world with this proviso is Israel. And we'll talk about that under policy wrinkles. Other things that went on, U.S. Export control of satellite technology was moved from state to commerce, which was an indication to many people that we were loosening further. It's not the Department of State deciding now, it's the Department of Commerce, which is probably going to be much more inclined to let the stuff go because they're into business and promoting U.S. interests economically. What else happened? Basically, it was 96 when they got the authorization bill that limited collection of data in Israel. 97, we get the first launch attempt. It failed. What else? April, we had another launch attempt by space imaging, which failed. And finally, in September, we got a bird. So we are now in the era of spy satellites, and that's how we got there politically. It's told much better in my paper, so if you want to know the ins and outs, you can read it there. Basically, it moves slowly over time. That's my conclusion, but we're there as things go today with a satellite in orbit. Okay, let's see if I can get this to work. There it is. Here's the current policy. There are no restrictions on resolution of commercial systems. IKONOS 2 is at 0.83 meters. That shot that you saw of the Washington Monument is essentially almost 3/4 of a meter in resolution. Basically, that means the smallest object that you can detect on the image, it's really related to pixel size, I believe. I don't know the details, is about 2 feet across. All commercial systems must be licensed by the Department of Commerce, who consults with the Department of Defense and the Department of State. That means if you want to launch a high-resolution system, you've got to go through all the hoops to the Department of Commerce, who then talks to Defense and State and makes sure there's no problems in their camps. It's not a very long process. I don't know how long it takes to build up the application, but they're supposed to respond within 90 days. So it's a 3-month process to get it okayed. Satellite companies can apply to provide turnkey systems to foreign operators. This has not happened yet. The applications are reviewed on a case-by-case basis, which is basically political language for it's really hard to get it, and they haven't okayed any yet. It's pretty dangerous. That's what they think, to just turn them over. Of course, U.S. companies who build satellites are very interested in doing this because they're worth a lot of money, hundreds of millions of dollars, a system like this. And so they want them to go, but they haven't been able to yet. Commercial operators, this is interesting, must keep orbit and tasking records and make them available to the U.S. government upon request. That means anybody who asks for an image anywhere in the earth, the government should be able to know about it. They're going to know. By the end of this year, when they finish when they supply their report or whatever to the government, or whenever they ask them to, they'll know every person who bought an image and where they bought it from. Everyone. And they'll also know the orbit of the satellite. Why do they want to know that? Those people who know about Area 51, why would the U.S. government want to know the orbit of the satellite and also know if there were any changes to it? Anybody here been in the military? What do they do when a bird passes over when you're in exercise? You cover up. The U.S. military needs to know when the satellite's passing overhead so they can cover up themselves. They're imageable. There's no place in the United States you can't image. You can image Area 51 if you want. They'd probably want to know who was buying that image, though, right away. But you can. So they need to know where it is at all times so they can do their job to keep U.S. military secrets under wraps. U.S. government reserves the right to exercise, this is the biggie, shutter control during times when national security may be compromised. Believe it or not, they were already in discussions about doing this during the Kosovo crisis when the first IKONOS bird was being launched. They were already in discussions if it would have flown successfully to basically shut it down over Kosovo. And this is really where the commercial people are upset, because there is a process for determining when national security is going to be maybe compromised, but it's not very opaque, and they're wondering what we can't supply images to people who demand them, even though we have this system working. So it's kind of funny that way. This is where we're going to see a court case under the First Amendment, for example, sooner or later. The first time the government, I've seen the brief They have it ready. Space Imaging has the brief ready. As soon as they exercise shutter control, they're going to file it with whatever the court, the appropriate court, and say this is a infringement of First Amendment rights, freedom of speech, freedom to collect information. The brief is ready to go. U.S. law prohibits providing images of Israel territory that are better than what is available through other commercial sources. This is the other piece. And this is a strange one. This is a strange one because the U.S. has argued internationally since 1955 that satellite overflight and image collection is legal. So why all of a sudden do we allow Israel to have the right not to be imaged? That's what people are asking. And they have it. It's in the law. It's already there. Wrinkles, which I've mentioned already to a certain point, is the Israeli blackout. Are other countries going to ask for it? What's going to happen then? You know, when who knows what other country would say, we don't want to be imaged either. The companies are at a disadvantage. They're obviously very much against the blackout, but there's not much we can do. There's also really kind of a chicken and egg thing going on here with respect to Israel. The Russians have a system called Spin2. Who's been on the Terra server site? Anybody been on the Terra server site? Okay, most of the images that you see, a lot of the images you see there are from Spin2, which is the Russian equivalent of Corona. It's a film return system they launch at request and take images. Spin2, it's called. They can image down below a meter, but what they release publicly is about 2 meters. So what's going on here? We have a system that can image greater than 1 meter, but they're releasing them at 2. We cannot image Israel at greater than 2 meters because that's the greatest resolution we can get out of the Soviet system. So they're all kind of playing this game. Who comes first? Who's going to drop down first? And it's really kind of complicated and hard to figure out. Basically, right now, we can't image Israel at less than 2 meters, but what are the Russians going to do now that we're down to 0.83 everywhere else in the world? They could decide, well, let's drop our image down to a meter. And then the U.S. could go, okay, well, they're down to a meter. Now we can image Israel down to a meter. So there's going to be a funny little piece working its way out here. Yeah.
Is this American policy, or do you hire a French satellite?
Nobody else has a system below a meter. The best French system is the Helios, which is still military. They don't release their images. The best imagery, other commercial imagery, is the Spin2 imagery from Russia. And it's really inconsistent. The people I talk to says you get it from different sources, and it's sometimes 2 meters, sometimes 5 meters. It's just not a very good system. Basically, it reflects their technology. But the best you can hope for, besides IKONOS, is a 2-meter Spin2 image at this point.
Stopping the French from, could an American company give the French the blueprints to satellite and have them launch it and then?
Yeah. The turnkey is allowed. It's not been allowed yet, but that's. I mean, you can see how this is all just going to evolve into, you know, a very high-resolution commercial system anywhere in the world, but it isn't there yet. It's the wrinkles kind of getting ironed out. Yeah.
I've got 2 questions. What keeps an American company from just outsourcing some of its stuff and just open up its company and then
Export controls. That's the stuff the Department of Commerce handles. They watch that stuff.
And the second question: how long do you think with the international competition you are able to uphold these policies?
That's the question. It's not a U.S. system. No, as far as I know, the first international. This is another interesting wrinkle. The first international system less than a meter, non-U.S. system less than a meter, is going to be an Israeli company. Believe it or not. They're in partnership with it's a company called West India Space, and it's an international consortium. But they are supposedly working towards a very low resolution non-American system, very high resolution. So, yeah, I mean, you're right. You know, it's kind of, they're putting their fingers in the dam, but it's going to happen sooner or later. It's going to happen.
Is the military telemetry encoded as it comes down, or can anybody build a receiver and get military images?
Yeah, it's all coded. It's all encrypted. I'm pretty sure. I doubt that they'd allow that to happen. The other wrinkle is, how is shutter control going to work? This is where the commercial people are kind of upset. They're ready. They're ready to contest this as soon as it happens. You know, who determines if national security is at stake? Obviously, it's Department of Commerce in consultation with DOD and Department of State, but they want to have that opaque. They want to know when things are going to get shut down, and it just hasn't happened yet, and they're waiting for it to happen so they can work out that policy wrinkle. What happens if the policy companies don't comply? Anybody know what the U.S. military is planning to do as a last resort? Yeah. Shoot it down. We have anti-satellite weapons that would take it out. And I guarantee you, if space imaging didn't play by the rules for long enough, they'd do that. They wouldn't hesitate a second. They'd take it right off. I don't know if they'd owe money for it, but they'd take it out. Basically, it's fuzzy. Shuttle control is fuzzy. Just tell you a little bit about the workshop that we had here in November, called Assessing the Implications of Very High Resolution Satellite Imagery, 2-day national workshop. We brought in 11 presenters from academia, industry, military, U.S. government, and foreign governments. Had a guy from West European Imagery Center who showed us some data that they've done over Kosovo using SPIN2, using the Russian data. Very, very interesting data set. He put it on my machine, but then he couldn't let me leave him. I couldn't leave his side until after he took all the stuff off. So it was still fairly sensitive material. We talked about the legal, environmental, and military, political, economic, and moral implications of spy satellites. It was the first public display of IKONOS imagery outside the internet, so that was here at Purdue. When I first saw that image of London in the wheel, I was pretty taken. It was a really nice picture. Give you an idea of some of the highlights. Cass Green was the woman I said who went nuts about the 11-bit power in this 11-bit data. She was just beside herself. She just said, for people who do work like I do, imagery classification, this stuff is going to be outrageously valuable. Master Sergeant John Weber is part of the Air Force's Red Team. What they do is take off-the-shelf technology and information off the internet and show the military what they can expect a terrorist organization to be able to find out about it, for instance. And so they're obviously buying IKONOS data and using that to some degree with off-the-shelf technology to show the Air Force what they can expect an adversary to do. He liked the idea. He thought that it's going to make the U.S. stronger because basically with people like me doing my job, we'll know what our adversaries are able to do and we'll develop countermeasures. John Tuvert was the guy from West European Center who talked about Kosovo. He had a map of Kosovo down to 2 meters. Bruce Marks talked about the potential use of the imagery. This is all in the report, by the way, for law enforcement. And basically the one-liner is, you could have seen the white Bronco. I mean, that's what the people in the legal profession say. Yeah.
Is all the data you see from the satellites images, or do you get videos?
It's digital. You get it in digital form.
Well,
Oh, it's not a video. No, it's a snapshot. There's no video. I see your point. It's not motion. A guy named Christopher Simpson from American University talked about the fact that it isn't just what this stuff's going to be used for. There was a lot of cheerleading going on at the workshop. He said, what about what it's not used for? What about the organizations like human rights and perhaps environment where this stuff isn't really channeled into? It's used for other things. And so he was just careful to say, you know, it's not just what it's used for, it's what it's not going to be used for. It was kind of an interesting take on things. Jean-Yves Bouchardy from the UN spoke about how they're going to use it for refugee monitoring and camp planning. I mean, that's what they do, right? His organization, or the organization he works for, maps out huge refugee camps with satellite imagery and helps them plan water and those sorts of things, how to find water and whatnot. And finally, Alan Margolis, a friend of mine from the EPA, reviewed the implications for privacy in the Fourth Amendment. And his conclusion basically was the resolution isn't good enough really to have serious privacy concerns, although, you know, you could pick out somebody's pot plants in their backyard if they had enough of them. And is that legal? The law says it is. The law says you can use remote sensing to locate illegal activity and then bust people based on that information. But that's kind of, in fact, the two cases that push this envelope the best are dope growing cases. So that's why I went there. To end up, give you some really pretty images from IKONOS. These guys sent them to me. There's the Hollywood Hills. You can see the sign. Pretty amazing. And Hoover Dam. I don't know. I haven't had a chance to get this imagery and use it in a really nice image processing software, but I have a feeling that it's going to be a pretty cool thing. I would suggest people who have perhaps in this point in their career, early enough in their career, if you're looking for a job and you do imagery analysis and you learn how to analyze this data, you will be able to go anywhere in the world. Every government in the world is going to want people who know how to analyze this stuff. Every company, sooner or later, large corporations are going to have people looking at this stuff. So if you're thinking about a career in imagery analysis, I would point you in this direction. Basically, high-resolution digital photogrammetry, if you can find a place to study it. Yeah?
Does IKONOS have a stereoscopic capability?
No, it's not stereoscopic yet. Somebody will launch one, though, sooner or later. That's what Corona had. Corona had a fore and aft camera that gave you stereo. So I can answer questions if anybody has any about commercial spy satellites. That's the long and the short. There's quite a bit more information up here if you're interested. Yeah.
What do you expect the government is now using for their everyday spy satellite resolution?
I mean, I've heard all kinds of different things, but I've heard it's down to a few centimeters, which I would guess somewhere between 10 and 5 centimeters.
Oh, that course. I heard it was smaller than that.
It could be. I know that they have a new system that nobody talks about, and that may be what you're relating to. I'm pretty sure that the KH-11s are around 8 centimeters, 7 to 8 centimeters. So you can't quite read newspaper from space, but you could probably see somebody reading the newspaper.
You can read license plates.
One of the images I didn't get a chance to pull down that I wanted to was from the very beginning. Space imaging is saying it's not good enough to see people. It's not good enough to see people. The first thing they did in the first international image that they released was of Tiananmen Square, and you could see the people lined up to go into the mausoleum. And they were like, "See, we didn't know what we were talking about. This is really, really good data." Yeah.
How about the NSA when AT&T first started using satellites for their communications? They built like satellite dishes next to AT&T, so they just got everything in there. Is there a similar thing with this that they're just kind of building like stations next to the receiving stations so they can see what everybody else is taking pictures of? No?
I don't know what you're asking. I didn't follow you.
The government wants to monitor who's taking
Oh,
what,
oh, I see.
like, build stuff or,
One thing is the largest, in fact, the only reason that space imaging got a business plan sold to the finance community was the fact that NEMA, National Imagery and Mapping Agency, which is the mapping agency of the U.S. military, agreed to buy about $1 billion a year worth of their data. So they're using it.
Why would the government want to use it when you think they already have?
Different characteristics. Maybe it's difficult. Well, there's restrictions, for instance, on the secret data that they can't apply to certain applications, so they won't want an open source. And now that it's available, they can just purchase it as they need it. I mean, if you build a map from, KH-11 imagery, you're going to be, in a sense, telegraphing your abilities to if it's in the open. And some of the NEMA stuff is in the open. A lot of it's classified, but some of it's in the open. Anything else? Well, I enjoyed the time with you, and if you want to read a little bit more about what's going on, it's down here. Very exciting area.